Hi, welcome to Clubhouse Kids. Today we will be working on learning about surface tension. So we'll be doing 3 experiments on surface tension. Before we begin, if you want to do this experiment yourself, these might be items that you have at home and that you can do. So I want to encourage you to try it. So things that you will need for this experiment. You will need a penny. You will either need a baster, or if you happen to have one, a syringe at home. This works a little bit better because you have a little bit more control than the baster. But the baster is workable. It just takes a little bit of practice. You will also need a bowl of water. You will need some pepper. You will need soap. You will need some milk and food coloring. So this will be for all 3 of our experiments. And I really encourage you to try this at home because it's fun. So our first experiment, talking about surface tension. So what is surface tension? Well, have you ever seen a bug walk on water and wonder why a bug can walk on water and we can't? Well, that's surface tension. Have you ever wondered why a drip of water kind of looks like a teardrop? Well, if we look here, teardrop form. That is surface tension. So what it is it's water molecules that cling to each other and don't want to let go. All right. So as the water molecules cling together, they kind of hold on tight. And if there's no other water molecules on top of that, like the top of a pond or top of a lake, then you get surface tension because they hold on a little bit tighter, kind of like your skin, together, and it kind of creates kind of like a little wall of water molecules that hold tightly. So what is a molecule? Well, molecules are made up of atoms, which we have talked about before in a different Clubhouse session, reminding atoms are the basic building block of everything. So they're different atoms combining together, creating a chemical bond. So if we take water, for instance, water has 2 hydrogen atoms and 1 oxygen atom, and they combine together and they make a single water molecule, and they're so very tiny. So our first experiment is going to show you kind of how surface tension works. All right, so this is a little bit hard. I'm gonna have to move my camera around a little bit so I can get the best angle for you to see. If you see here, I have a sample penny, my sample, and I have a penny that I'm gonna drop water onto. All right, here I go. See the difference between. So as I drop the water, it's not running off the penny unless I shoot it out. The syringe is not very good. And as you notice, it's kind of forming a little dome. So once I squirted too hard, I'm actually breaking the surface tension, and that's why if you notice on the counter, it kind of lays out in all kinds of directions. But let me try my dropper here. As I drop water gently onto the penny. I need to clean up real quick. Science doesn't always work the way you want it to. I use my other syringe to clean my dog's ears out, and that's why it's not quite working as well. All right, so I have this penny and this penny. I'm going to try this again with this syringe. You notice it's starting to kind of form a dome. On the penny. All right, so can you see that there's kind of a dome formed on the penny compared to this one? All right, you can kind of see it wiggle and jiggle. Well, eventually, like if I add too much water, that surface tension that's holding those water molecules together so tightly is going to fall apart and all the water will fall off the penny. Use this one. So as I drop drips of water and I overload my penny with water, let me clear it away so you can see a little bit better. I still have my dome there. I haven't broken the surface tension yet, if you can see. Let's see if I can get a better angle. Now I've broken it. So now you can no longer see the dome. All right, so the next experiment we're gonna do is one with pepper and your finger. So I want you to be able to take, let me set this back down, a bowl, and you're going to take some pepper. And you can use a pepper grinder. The pepper flakes are a little bit heavier, some will sink to the bottom, but enough will come to float to the top. So I'm going to sprinkle some pepper in my bowl. All right, and these peppers kind of act like little insects. And so if we notice, they're just floating on the top of the bowl. Okay, what I want you to do next is take your finger, and I want you to stick your finger in the bowl. So as I stick my finger in the bowl, watch what happens. Like I can try to get the angle right. And pull your finger out, and your finger is awfully dirty. So now I want you to clean your finger off. And this time I want you to take your soap, and I want you to put, let me get the camera angle right, a drop of soap, and it doesn't have to be too big, a drop of soap, or if you have a bar of soap, you can just rub your finger on it. Take your soap, and now you're going to put your finger just gently on the surface of the water and see what happens. Well, now the soap didn't do anything to the pepper, but the pepper moved, right? And moved away from your finger. Well, it was the soap's actual reaction with the water molecules. The soap was breaking down the water molecules and causing the surface tension to move away, to kind of crumble. So that's why there was movement in the water. As the water cubes moved away, it caused the surface tension to break, and it moved the pepper away from your finger. All right, one more fun trick to do with surface tension. As I mentioned before, surface tension doesn't just have to be doesn't need to be water. It can be any liquid form, and so that's going to include milk. So on this next one, I'm going to take probably a shallow bowl if I have it. Any bowl will work though. So if you just have a regular cereal bowl or soup bowl, that will work fine. But for the camera, I'm just going to do a thin layer of milk. And the fattier the milk you have on this, the better. But if it will work with like 2% or 1% milk. So I've poured milk in my bowl here, right? Now I'm going to add droplets of food coloring, right? And this food coloring is going to represent bugs as well. So as we drop it, at first it kind of breaks that surface tension a little bit, but then it kind of floats back to the top, the majority of it. And, oh, I forgot a Q-tip. Let me run to my laundry room and I'll go grab a Q-tip. I forgot that was another part that we needed. So I'm adding a bunch of different colors because it's kind of fun. This is kind of an art project as well too, to my milk. So you can just add one color if that's all you have. That will work just fine, or you can add all the colors. It all depends on you and how much you want to add. I'll be right back in a second. All right, I'm back with my Q-tip. So next thing I want to do with my Q-tip is put some soap on it. Sorry, this is like the third or fourth time I've made this video, so hopefully I'm getting better in quality. My other one I made was good, but it was turned on its side and couldn't have that. So I put soap on the tip of my Q-tip, bring it around a little bit. All right, what do you think might happen once I put the soap, a little bit more, soap into the milk with the dye? Do you think it will break the surface tension? Okay, let's see. Ooh. And I'm just gently putting it on the food dye. If you watch, kind of makes a beautiful pattern in the milk. Well, what's happening is that the milk has a lot of fat in it, and the soap is breaking down the fat, much like it broke down the water molecules. It changed its compound. So it's breaking down that fat, and it's breaking the surface tension at the same time, because the fat molecules are also something that was holding that surface tension together for the liquid in the milk. And it's kind of fun just to play with. So I hope you enjoyed this lesson on surface tension, and I look forward to making another different science video for us later. Bye.